Hello guys, hope everybody is doing okay. This is video number 2 of a series of 4 videos, or maybe more, who knows, about the Franken Rotor DIY build. And today's video will be talking about the Rotary module, the rotor by itself that is down there. And let me give you a quick update here about why the idea I came out to build this machine. First of all, I love building machines. That's my hobby. Not making quick, cute things and stuff like that. Just making the machines is my passion. So why I did this? Let's start it. Let's go here to the this is the Franken 40 cube, and it's a K40 machine that is not in their case anymore. And as you can see, you have a Rotary controller. That's 6445 one. 6442 is the same, just the difference is the panel, fancy numeric keypad on it, and maybe a couple more switches on it. And I decided, say, hey, you know what? I can make a rotary device inside this machine underneath my normal cutting table. So I did it. So let me show you real quick here. Let me remove the cutting table here real quick. And you can see this machine have a rotor device built in the machine that doesn't have to be removed from it. And I can just move it out and down. But check this out. This machine is capable of cutting 12 by 12, maybe 13 by 13. But when you put all these things on it, you're limited. Maybe I just did a 30-ounce tumbler, Yeti tumbler out of it. Maybe it's I don't know, maybe 2 inches, an inch and a half more than this one. But that's it. So then I say, whoa, I got a bigger machine down here. So let's make another rotary device for this one. And actually it's underneath this cutting table. You can see the driver down there. And well, let's see, this thing doesn't have too much room down there. I think maybe like 10 inches C-axis, up and down, due to the factor that everything is built inside this housing. The good thing about this machine compared to the Rotary is one thing. This thing have a dedicated axis for a rotary device that you can assign, and you can have all your gantries locked during a rotary engraving situation. The thing with this Rotary controller is that you need to use only the Y. So how that thing works is crazy. Right now you can see this thing is locked right here, and this thing is locked right here because it's in the normal phase of engraving like a normal cutter. But now with this machine you need to switch drivers back there, because the only way you can engrave rotary devices is using exactly the Y-axis on this. So you need to have a switch, cable back there, and then you have to disable the normal one. Boom. And now this thing is loose. You bring it down there, and let's lower the table a little bit. Move this thing around and spin the guy. But during the engraving process, this thing is loose because it's on power. I don't like that at all. I hate it. This machine is very greased out. This thing is, for me, actually, it's almost my favorite machine that I have for cutting. This thing rocks. But this thing loose during a job, you can imagine this thing going like, I don't know, maybe 200 millimeters a second to the sides and this thing loose. That's the way it works, and I don't like that. So what? I just came with the idea to have a dedicated machine. Here, we're about to talk about this guy. This guy came from the idea of this thing right here. If you notice, this is a normal tabletop friction rotary device. Very similar, or even very similar to the Randy Smith from Olga Mods. Is very, very similar to it. I just took a couple ideas from him, and actually I used his wheels for my project that I bought from him. And for me, this is one of the best type of rotaries that you can have. So what I decided is, okay, I want to take it and make some modifications on it. So let's take this thing apart here, and let's bring the other one. This guy, let me see if I can grab this thing with only one hand. Bear with me, guys. Oops. Very easy to remove because it's a separate module. And let's bring this guy here so you can take a look. There we go. So as you can see, it's a normal friction type rotary device with free wheels on the other side. Only difference that instead of having cast corner brackets holding the post right here, I have this thing on wheels, and I have a Z-axis with a manual jogging knob on the top, so I can adjust my focus very, very precise when I want it. If you can see, the stepper motor is back there. The clearance from the stepper from the plate is only like 3 millimeters. You can barely fit a piece of wood back there. So basically, this is it. So it's built on top. This is a 20 by 60. B-slot rail and extrusion, I'm sorry, and another 250 vertically to use as my C axis. And another thing here is a anti-slip wheel that goes inside the material, the object, to avoid some slipping to the sides. So that's basically it. So here you can see all the pieces or the parts needed to build one of those. We're talking about almost 100 parts due to some little parts that goes in the wheels, and we need a total of 12 wheels to build this thing. We need the Acme 8mm lead screw nut back there. I cut all these plates out of acrylic. This one is the original Open Builds universal gantry plate that is right there. And here is the main rotor plate that is already, I already pre-assembled a couple things. You can see there is a acrylic bearing holder in both sides, and that's to hold the bearings of this mechanism. And already have the 40 feet GT2 pulleys already on it. And obviously stepper motor, the wheels, and this to hold the lead screw for the Z-axis. So that is basically it for this thing. Another way to do this, if you can handle this, you can have a device like that, but We are talking about a 20-pound device. If you're planning to buy one of those, be sure that your seat table, if you have one, can handle 20 pounds plus the weight of your own seat table. That thing is massive. That thing is huge. And believe me, if you don't have an AC motor on it, or at least a NEMA 23 running out of 48 volts with a very big driver on your seat table, forget about that kind of device. You're not gonna be able to handle that. It's 20 pounds in weight. So you ask, what the hell this guy have like all the pieces, to be, like ready to build another thing like this? Yeah, I'm making another one because I'm gonna have two of them installed in here, so I can work with two different pieces at the same time. That's the whole idea. What I'm building another one of those rotor devices for this build. So guys, if you have any questions about anything, I already updating the page at Open Builds, how I build this and all the parts, details and all that stuff. It's not that hard. There's a lot of work involved here, but it works and I love it. You can see some tests that I did already here. And check this out. You see that Bacardi bat right there? So wide. Guess what? I forget to do something on the settings. Then I came to the other side and said, okay, look, this one looks much better. So there's a lot of things that you can do, with this thing. And another thing about what I decided to go with this is in order to make big things like baseball bats and stuff. Or maybe I can make a hole here in the machine and I can pass through materials to it. So that's the whole idea. Keep going, guys, and the next video will be about the enclosure of the machine. It's very easy to build also, and there is no cutting necessary about the aluminum extrusions. And the only thing you have to cut is the acrylic. And those acrylic parts, most of them are 12 inches. The biggest one, tall white stocking, that you can even use that thing to cut it. And then after that, we'll be talking about also the electronics. And back there, that's very simple. See you around, guys. I hope you enjoyed the build. See ya.